Remember, speciation is the formation of a new species, okay, and as a general rule, that's going to happen usually due to isolation. Okay, so we said that the genetic drift could lead to an increase in speciation, or the increase in the rate of speciation. The founder effect, that population is usually isolated. In the bottleneck effect, you've reduced the amount of alleles that are available because you've reduced the population so quickly that it could become isolated on its own as well. Let's take a look very quickly at some of the different ways that an organism can be isolated that can lead to speciation. Okay, one of them we've been talking about in class, geographical. A river, a mountain, they'd be physically separated. So geographical isolation could lead to the formation of a new species. Okay, we've also talked in class about reproductive isolation. And there are two forms of reproductive isolation. You could have gametic isolation, where the two gametes do not come together anymore. Okay, for instance, sorry, I was trying to make this smaller for you. Okay, so for instance, this picture here with these starfish, okay, these are sea urchins, I'm sorry. These particular sea urchins here, they release gametes into the water, but their gametes are incompatible with one another. So they can live in the same place, but they are still reproductively isolated. You could also have mechanical reproductive isolation. Mechanical isolation would be that literally anatomically the two organisms are reproductively isolated. They anatomically cannot mate. Okay, you can also have habitat isolation. Okay, these two frogs here, okay, they live in two different places. One spends more time in the water, one spends more time on the land. So they are habitat isolated. They're not separated geographically, that's just not their preferred habitat. Okay, you also can have behavioral isolation. Okay, so with behavioral isolation, they may be looking for their mate to do a certain song, perform a certain dance, okay, and until that happens, they won't mate with them. And so other organisms that don't know what that is, what behavior that is to do, would not be able to mate with them. And then last, we can have what's called temporal isolation. Okay, temporal isolation deals with mating times, okay, and basically when the organism is ready to reproduce. And if temporal isolation occurs, that means that these organisms are reproducing at different times in the year. If you look at your graph here, you've got these 4 different kinds of frogs that all have their peak mating season at different times of the year. So the bullfrog and the wood frog are not going to mate because in March and April, when the wood frog is ready to mate, the bullfrog is not. Scientists have 2 theories that are based upon the fossil record to help explain the rate of evolution, so how fast evolution is occurring. Like I said, both of these are based on the fossil record, and part of it is based on the fact that the fossil record is incomplete and has gaps. So the first one is what's called gradualism. Okay, and so again, we're talking about the rate of evolution here. And so gradualism, basically the theory states exactly what its name says, that this is a slow and steady, continuous change. Okay, so evolution is constantly happening. There's lots of intermediate species here. Okay, that there is slow, steady, continuous change that is occurring over time. You can see on my x-axis here I have change as I go to the right and to the left, and my time increases on my y-axis. So as my time increases, I'm getting more and more change. Okay, so that would be gradualism. The other theory is what's called punctuated equilibrium. And punctuated equilibrium believes that there is long periods of stasis or periods of equilibrium where there is no change happening. Okay, so there's long periods of stasis. You can see this on this picture here. You've got long periods where there is, I'm sorry, I circled the wrong spot. Okay, you've got long periods of time where time has changed. Okay, so I've changed in time, but I have not gone either direction side to side, so I haven't done any change. and then there'd be periods where there's lots of rapid change, but that's not over a long period of time. Okay, so punctuated equilibrium, again, I've got long periods of stasis or no change with brief periods of very rapid, very quick change. So, like I said before, both theories can be supported by the fossil record. So, let's look at the gradualism. Remember, this is our slow and steady change over time, constant, continuous change. And the support for the fossil record for gradualism comes from the gaps, okay? And the fact that there are gaps in the fossil record being due to that the formation of the layers of the rock was never formed. There's a gap in the formation of the rock layers. As you can see on this one here, the dotted areas, these are all things that were not preserved, which would indicate a period of time where the rock layer wasn't formed. Okay, and there are gaps in the sedimentary rock, and so there are periods of time then, if the rock layer wasn't formed, then how could the fossil be formed? And so that would explain why we don't have a fossil for necessarily every single one of those different species, those intermediate species that would be there. Punctuated equilibrium also has support in the fossil record. Remember, this is the one with my periods of long periods of time where there's no change, and then there's very rapid change, okay, punctuated by very rapid change. So punctuated equilibrium also the support comes from the gaps in the fossil record again. And so punctuated equilibrium believes that the change happens so fast in the geological time, the amount of time that it would cause that there would be for the rock to form is basically just not fast enough. The rock isn't formed fast enough. So the change is so quick that you don't have these intermediate fossils because there was not enough time. Basically, they weren't around long enough for the rock to form, fossils around them once they had passed. And so in this one, you see that you have this gap in the fossil record, okay, which again would be due to the rock formation not happening fast enough. And many scientists believe that both of these things occurred, that there are periods of gradualism in evolution as well as periods of punctuated equilibrium. Depending upon which theory you're talking about, your phylogenetic trees in your pictorial depictions may look a little bit different. Okay, so this one over here on the left, this would represent our gradualism, the winding lines, the slow, gradual, continuous change, where over on the right here, okay, this would represent our punctuated equilibrium, okay, where you can see these very definitive periods of no change, followed by the very rapid, very quick, okay, interrupted by the very rapid, very quick areas of change. So we'll be working with this vocabulary. That's what a lot of this is, just vocabulary review coming up in class.